This paper was published in Astronomy and Astrophysics. It explores topics such as eclipse, binary stars, doubly eclipsing, light blending, and crowded sky. Let's first hear a simple explanation.
Are many new double-eclipsing star systems actually already known? Stars can come in pairs or groups that orbit each other. When one star passes in front of another from our point of view, it makes the light we see get a little dimmer. This is called an eclipse. Telescopes and sky surveys look for these dips in light to find, eclipsing, star systems. In very crowded parts of the sky, like the center of our galaxy called the bulge, lots of stars sit close together in the images. This can cause blending, where light from different stars mixes and looks like a single object. OGLE is a big survey that already searched many crowded areas and found lots of eclipsing stars, so new searches need to check against OGLE's list to avoid re-reporting what's already known. The author checked 245 stars that were reported as new doubly eclipsing systems, meaning two separate eclipse signals. They found 53 cases where the signal actually came from a nearby already known star, instead of being a true double system. That means about 1 out of every 4 reported new systems was a blend or contamination, especially in the crowded bulge areas. If many reported discoveries are actually blends, scientists can be misled about how common certain star systems are and might waste time following up on false leads. It's like thinking you found a new kind of bug in a photo, but it's just a shadow from a nearby insect. Checking earlier records and using clearer images helps avoid mistakes. Future studies should double-check crowded regions and compare with older catalogs like OGLE, so we don't count the same stars twice.
Ready for the next level? Here comes the science explained with real research terms.
Are many newly reported double-eclipsing stars actually already known blended stars? Stars that orbit each other can pass in front of one another from our point of view. When one star blocks the light of its partner, we see a dip in brightness called an eclipse. A doubly eclipsing object shows two such different eclipse patterns, which can mean two separate pairs of eclipsing stars seen close together. Telescopes that scan crowded parts of the sky, like the Milky Way's bulge, can confuse light from nearby stars. Their images blend together like multiple flashlight beams overlapping on a wall. Large surveys such as OGLE have already cataloged many variable stars in those crowded regions, so new detections need careful checks to make sure they are not just light from a nearby known star blended into the target. The author checked 245 stars that were reported as newly discovered doubly eclipsing systems and found that 53 of them, about 1/4, are not true new double systems, but instead are blends, signals coming from already known nearby stars, mostly listed by OGLE. The problem is worse in dense bulge fields where nearby stars overlap more often. If many new discoveries are actually redetections of known stars, then our counts and statistics for multiple star systems will be wrong, like thinking a flock has more birds because you counted the same bird twice through a fog. This can waste telescope time on follow-up studies and lead to wrong scientific conclusions. The work shows astronomers need careful checks, higher resolution imaging or catalog cross-matching when claiming new discoveries in crowded sky regions.
That's it for today's paper. Thanks for tuning in. See you next time.